Hello friends, I'm a cloud solutions architect at Microsoft and my aim is to create free resources that will empower every single engineer in this world so that they can do better with their technical interviews. Now continuing in that direction, today we are going to solve a very important problem called regular expression matching. So let's get started with the problem. So if we see some of the popular companies who have already asked this question, there are companies like Microsoft, Amazon, Facebook, Google, Bloomberg, Adobe, Apple, Uber, Snapchat, Tesla, Goldman Sachs, and Airbnb. So that's why I'm paying my utmost attention. I hope you also enjoy the video. So this is a LeetCode hard problem and also a very well-liked problem. Basically, we are given two input strings. One is string S and the other one is pattern P. Now we need to implement a regular expression matching function that can support a dot character and a star character inside this pattern P as well. Now we are given the definition that what does a dot and a star represent. Basically a dot can represent that it can match any single character and the star represents that it can match 0 or more preceding elements. Now first let's try to understand both of these with examples. So suppose we are given a pattern P that looks like A, B and dot. Now dot by definition it can support any single character. Now inside our given string S, suppose we are given the values to be A, B, C. Now can we conclude these two to be matching strings? The answer is yes. Why? Because for this particular dot we can consider it to be C because it can match any character. Suppose if we are given an S that looks like A, B, X, is it true? Yes, this is also matching with this pattern P because for this time for this dot we are actually considering it to be X. But if we are given S that looks like A, X, is this matching? No. Why? Because the second character over here, this is A. Meanwhile, the second character inside our pattern is B. These two are not matching, so this is not a matching sequence. So basically this is what does a dot represents. Now let's try to see one example of what does a star represent. So basically suppose we are given a pattern P that looks like this where the values are again A, B, star. Now what does this star is saying by definition? The star is saying that it can match 0 or more preceding elements. Now what is a preceding element of this X? The preceding element is B. So which means that now this particular pattern can match bunch of different other strings. So strings such as A, B, 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 B. Does this match this particular pattern? Yes. Why? Because if we see, okay, first character A is matching each other. Now for the second character B, we can have multiple B's over here because of this star value, because that is what is given in the definition. So based on the definition, we are now in this case considering the star to be all of these B's. Suppose we are given a string S that is only A. Is this matching with this pattern P? Yes, this is also matching. Why? Because this star can represent that we have 0 or more preceding elements. So in this case, we are considering that we have 0 B's in the pattern, which means that our given S is actually matching. And in this case, since both of these are matching, now let's try to take one more example. Suppose our given S is equal to like A, B, X. Is this matching? No, this is not matching. Why this is not matching? Because this AB portion, this is matching, that is good. But we do not have an X over here, and that is why this is not a match. Does this match? And pause the video for a second. Try to guess that whether this matches or not. Let me come up with the answer. The answer in this case is that this is actually a match. Believe it or not, this is a match. Why this is a match? Well, okay, first F is matching. This is good up until this point. Now, because we have a star with dot, which means we can have n number of occurrences of dot. And we know by definition that dot can represent any single character. So in this case, what we are going to have is, we are actually going to have 7 different dots. And these 7 different dots, they are going to represent each character that is missing in the remaining string. And then eventually when we reach to the end, we are going to declare this as a match and we will be able to return true in each of the cases. So I hope after so many examples, things would make sense and you would get the idea that what this problem is asking us to do. Basically, we need to return a Boolean answer, whether true or not. that whether any given two strings, do they match or not match. Okay, now before we come up with the solution, first let's see that what could be the different possibilities for our problem and what could be the different things we can do in the solution. Now I have drawn a table over here where I'm representing different like string values and pattern values, and we'll try to see that what happens in every single scenario and what are the actions we can take. Now I have noted that there could be like a C mentioned over here in this column file, and this means that it could be any character from A to Z, because in the string we can only strictly have A to Z characters. Meanwhile, for the pattern we could have definitely C, or we could also have a dot and a star. So that means different things, and if they are present we might have to do things a little bit differently. So first let's see the first scenario. In the first scenario, basically both the values we are given is like a simple character. So for S and P, suppose we are given the values like A, B, C and X, Y, Z. This is pretty simple to match that whether the string matches the pattern or not. We simply need to judge character by character. In this case, we can simply see that whether they are matching or they are not matching. This is a very simple binary operation. Second option we can have is the most beautiful option, that whether we are given one character and we are given a dot value. This is also very straightforward. If there is a dot present, definitely it matches the character. We can simply return that there is a match for that particular character. Second scenario is that we could be given bunch of different characters, and we could be given like some characters at the beginning, and then we might be given like a dot and a star. In this possibility, basically what we need to check is that whether like a single character like this first character, and whether this first character, I mean this could this could represent like more characters. These could represent something like a and like a dot star, something like that, right? There could be like different matching things. I'm just noting down C. But this means that if like the before portion matches, everything at this position is definitely going to match. So in this case, if like the values before the dot and star matches, then everything is a match, right? If we take a look at this example, basically we are simply given dot and star. In this case, 100% there is going to be a match. Why? Because all the values that are present over here, we can take like 0, 1 or bunch of different dots, and all of these dots can represent all the characters that we have. Now comes the interesting part where we are dealing with a star. What could be different possibilities? So let me give you like one possibility. Suppose for this our string and P value, we are given the values like A, B, and over here we are given the values as A, B star. Question is this a match? Yes, this is a match. Why? Because this is the first value. This is a match in itself. And over here we only have one value of B. Now over here we have B star. So this B star could represent that we don't have any values, or we have one value of B, or we have two values of B, or we have infinite values of B all across like the board, whatever we want to choose. So in this case, we are definitely going to choose one value of B, which means this is a match. So in this case, what are we considering? Value before the like preceding value of star. So value before preceding value of star. If that is a match, definitely we can find a match, right? There could be another possibility. We could be given a string, we could be given a P, we could be given a bunch of different values like A, B, X, Y, Z, A, B, X, Y, Z. So far everything is a match over here. And then over here we are given something like 2, 3, 4, 5 Z's, right? And over here we are given like just a star value. In this case, how would you define that whether this is a match or not? Well, definitely this is a match. But the way you are going to define is that the values that this Z and star that we are considering, like these values, before that we are checking that whether all the values that are present before that, are they a match? If all of these values are match, definitely we can create this to be a match. So again, we are considering like all the values before the preceding value of star. I know I'm using a lot of abbreviations, but you just have to be with me. I'm not going to write all of them. And if that is a match, we can consider this to be a match. There is also one more possibility where we actually do not need to consider this like preceding value at all. What could be a scenario? Suppose we are given string as is equal to like a, b, c, d, and over here we are given some p is equal to a, y star, and then b, c, d. In this scenario, this is definitely a match. Why? Because for this y star, we are considering this to be 0. If this is being considered as 0 values, which means that this is a match, and then all the other values, they are match. So we will find a potential match over here. So again, we are considering like if the value before the preceding star, if that is a match, then we can consider this to be a match. So now we are just like dealing with lot of possibilities where every single time for value inside the pattern, we will have to keep track of the value, like two value before that whether that is a match or not. And in order to calculate any single calculation, we are always checking that whether the values before us, are they matching or not. So this is a very good candidate for a dynamic programming solution. Why a dynamic programming solution? Because first scenario, we are definitely like using whatever the results we have calculated to check that whether the current result we are at, if that is a good or not. Second, already calculated results are going to give us the ability to decide that what do we do in the current position, because we are not only dealing with like simple characters, we are also dealing with like a dot, and we are also dealing with a star. So this is going to be really helpful. And we can use something like recursion to solve this problem, but that is going to complicate things. We are actually going to use recursion with DP, and that is going to make things much more easier. So let's try to take one example over here. And the question is, for a dynamic programming, we are not only going, because we are dealing with two different like string and pattern, it would be better to create a 2D matrix, and inside the 2D matrix, for every single like string and every single pattern, we will try to see that whether the characters match or not, and based on their true and false values, we would be able to calculate some interesting results. So let's see that in action with an example, and that would make things more clear. Okay, so currently we have created an example for a string and a pattern, and we need to check that whether they match or not. Now also for this pattern, I have created a 2 by 2 matrix where inside every single row represents the string value we have, and every single column represents a character inside the pattern we have, and we will try to see that whether there is a match or not. Now remember, for the first row and column, I have kept it as empty. Why? Because these we are going to use to create our base case. Now our base case is that currently for the string, the first character we have is empty character, and also for the pattern, the first character we have is empty character. Now, because these two are empty characters, definitely empty characters are going to match for sure. So in this case, this value is always going to be true. Now we will try to see that whether there is a match over here or not. So in this case, because this is an empty character and we have some character over here, there is not going to be a match. So definitely we would always be able to like have all these values as false. So currently we are at this first position. This value is f, this value is f. Both of them are characters, both are same. And when both are same, we will also have to check that all the values before that, if they are also match or not. So currently the only values before that were two empty strings, and that represents this diagonal corner. So because this diagonal corner was true and we have matching set of characters, we are going to take the value that is diagonally present and put it at this position for this 1 1 box. Again, I'm repeating myself that because these two characters are same. So first we check, okay, these two characters are same. Then we check its diagonal value, because what this diagonal value is going to do is it is going to check that whether all the values before these two values, are they a match or not. And this will come in handy when we are at some position like this, because if over here we find this a to be matching, which means this value is a true, but do we need to keep it as true? Because if this is false, which means if we are, say for an example, we have string to be FA and we have patent to be PA. So in this case, though these two match, but this is not a match. Why? Because this F and P does not match. So we can break out immediately. And that is what we need to keep track of every single time. And that is why this is a dynamic programming problem. So in this case, as explained, this is going to be true. Okay, now again, let's start filling up all of these files. And what we are going to do is, okay, this one is true. Now we will have to check that, okay, currently we have FA and the value we are comparing it against is F. Is this a match? No, this is not a match. So this is going to be false. Again, currently the value is FA star and the only value we have is F. Is this a match? Yes, this is a match. Why? Because for this A star, we can actually consider this to be an empty string or zero values of A. And if we do that, then we will have no values over here. So in this case, this F and this F is match. And why this happened? Because we had a star value over here and we were dealing with the star value. So now again, the new theorem comes that whenever we are dealing with a star value, we will have to check the value before its preceding value. Again, whenever we are dealing with a star value, we will have to check the value before its preceding value. And if that is true, then we can directly mark true over here. So we check, okay, this was true. So definitely we are going to put true over here. Awesome. Now we are at this position number n. Now currently, what is the scenario we are comparing? We are comparing the values of F, A, star, N, and we are comparing it with F. So N and F, there is no match. So definitely we can mark false over here. Now we add a dot over here. Again, there is a no match. So we can mark false over here. And same way, this is also going to be false. Okay, now we are at this position. So now we actually have two values, FA. Now for this FA, if we only compare it with this value F, is this a match? No, this is not a match. So we can mark false over here. Okay, now after marking false over here, currently we add this positions. Okay, so FA, definitely there is a match. So because these AA matches, we will compare its diagonal value, and the diagonal value we get this result, and we will mark the value over here. So this is going to be true. Awesome. Now currently we are at this FA star. So FA star, is this a match with this FA? Again, now we have the star value. So we will have to check. First thing we will have to check is whether we can consider this to be just like an F and empty string, or we can consider this to be an FA, or we can consider this to be an FAA. I'm talking about this value, right? And if we see this FA is a perfect match. So now because we have a star value again over here, we are going to mark this as true. But this true, we are getting it from the value before. Because remember, in this case, you must be wondering that, hey, for this particular position, this value is actually empty. Then why are we marking this to be true? We are marking this to be true because this one is true. Because we found a match of FA, and because this value is true, we will mark this as true. So let's do that. Awesome. Now currently the next value we have is like FAN, and this value we have is FA. So definitely there is no match. We will mark this as false, and if we add dot, we will again mark this as false, and blah blah blah. Right? These are all the values going to be false. Now currently we are at the position of FAA. Let me clean this up a bit. So currently we have FAA over here, and currently we only have F over here. So definitely this is going to be false. Again, this FA is also going to be false. Now again, we are at the critical juncture. We have a star value. Now because we have a star value, you must be wondering that what will be the possibility. Well, the possibility is, again, over here for this FA star, we can consider it to be like only F or FA or FAA. In this case, we are going to consider it to be FAA. Now you must be asking that, hey, previously when we were at this position, you mentioned that because this is true, we are marking this to be true. Then when we were at this position, you mentioned that though this was false, but because this was true, we were marking this to be true. Now we are at this position, this is also true, sorry, this is also false, this is also false. Then how come we are marking this as true? We are marking this as true because this value is true. Mind blown. Yes, this is like the most important point for this problem, that whenever there is a star present, we will have to check three different values. So whenever there is a star present, we were checking that whether the value before the preceding value, if that is true, we can mark this as true. If there is a star present, we will check that whether the value before this, if that is true, then also we can mark it true. And if there is a star present, we can check that whether the value above it, if that is true, then also we can mark it as true. Which means whenever we were at this position, if we don't want to get into all of these like calculations, all we need to do is that currently we are at this box, then we will have to check three different boxes. First box is the right, like before box. Second box is this one, like the box before box, and third box is a box above that box. So for this particular box, if either this or this, if any one of the value is true, we will need to mark that value over here. If all three are false, then only we will mark it as false. And why this happens? Because this was a star value and there could be bunch of different possibilities we can use over here. And this was the most difficult part of this problem, and congratulations, you understood it perfectly. And now because this was true, now currently we have this FAA, and now we have this like F. Now we are at the next value. So next value is FA star N, and this N is not a match, so this is going to be false, and then all the subsequent values are also going to be the false. Now this is a very easy problem to tackle, because now we are at this position N, so this is not a match, so this is going to be false, this is also going to be false, this is also going to be false. And now we are at this N and N, because these both of these are characters, so there is a match. Because there is a match, we are going to consider it's like diagonal value, so diagonal value is true, so this is also going to be true. Now this is a dot value and we only have values up until this point, so which means we are going to mark this one as false, and we are also going to mark this one as false. Now again we are at this value number G, so we all of these are going to be false up until this point. Now there is a dot over here and there is a G over here, which means there is a match. So if there is a match, we are going to compare its diagonal value. The diagonal value is T, so that is true. So because this one is true, this is also going to be true, and the last value is going to be false, because we only have value up until G up till this point, and we have this M over here. Now the last value is, okay, this is going to be false, 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 and this is also going to be false. Now we are at this last position. This M is a match with this M, so because this is a match, we are going to take its diagonal value, and the diagonal value in this case is true, so we are going to take this value as true. Now our dynamic programming table is complete, and all we need to do is we need to check this diagonal file, and we need to check this last value. Because this last value was true, we can return true in this case, and this would be the answer we need to return. And that is the whole logic behind this problem. And this was a very beautiful problem. If we were only dealing with the dot values, this would be much easy to solve, but because we were also dealing with the star value, it added a layer of complexity. Now if we see time complexity, in this case the time complexity is actually going to be big O of M cross N, where M is the length of a string and N is the length of the pattern. And if we see space complexity, because we are creating a 2 by 2 matrix, basically the space complexity is also going to be big O of M cross N. And this is a beautiful solution, like one of the best dynamic programming solutions I have seen so far. So I hope you would have enjoyed it. Now let's move on to the coding. First we will check for an edge case, that if both the values are null, we can simply return null. If that is not the case, we are going to initialize our dynamic programming 2D array, and for this 2D array, let's name it as DP, and we are going to assign the length of whatever the length of S is +1 and also length of P +1, and we are going to assign the base value of the 0 0 to be true. And now let's populate the first row. So this should take care of the first column. Now let's start our loop. So we are going to iterate over I and j, which means we are going to do two for loops. Inside the loop, we are going to check for all three different possibilities. So first possibility is that the given characters, the p is actually a dot. If that is the case, which means it would be able to match any single character, we are marking like the dp of I plus 1 and j plus 1 to its diagonal value. Now you must be wondering, why am I dealing with like I plus 1 and j plus 1? Because for the first row and first column, remember, we mark their values as 0 and we actually started the value of s and p on the first position. So that is why every single time I'm going to updating like I plus 1 and j plus 1 values, because the ith and jth value is actually located at like 0 0 position. They don't have any values. So if there is a dot present, we simply check the diagonal value. Now the second possibility is that both of them are characters, and if both are characters and they both match, we can also mark their value as same as their diagonal value. Now we are at the third possibility, and the third possibility is that if the given character, if that is in the pattern a star, if that is a star, then we will have to do some additional calculations. So now for first we are at the value star. So there could be two possibility. We could have some value as like character and a star, or we could have some value as like a dot and a star. So if there is a dot and a star, we only need to check that whether all the values before that, if they are match or not. And if that is the case, we would be good. We can mark it as true. And so first let's take care of the scenario that if the given value is actually a dot star. So now we have done that check, and then we will check all of those three boxes I mentioned, that if either one of them is true, we will simply add that value over here. With this value, we are actually comparing all of those three boxes. So if any one of them is true, we can mark it as true. And in the end, this concludes all the possibilities we can do inside our loop. So basically we are done with our calculation. Now simply in the end, we need to return that what was the last value inside our dynamic programming diagonal. That should be it. Let's try to run this code. Okay, seems like our solution is working as expected. Let's try to run this code. And our code runs pretty fast compared to a lot of other solutions, and which is really good. And it's great in terms of time complexity and also in terms of space complexity. And I would be posting this solution in the comments so you can check it out from there. Thank you.